right, good to be back. So we looks like we're looking at t being 4 pi thirds. So we're gonna take the sine of that 4 pi thirds, right? If you remember, we rotate that arc length was 4 pi thirds, right? Or 4 point something, whatever that is. It pertains to negative a half. So that thing pertains to that negative a half comma negative root 3 over 2, right? So there's your x, there's your y. So we're going to go through and we're going to say, well, the sine of 4 pi thirds is the y value, negative root 3 over 2. That's real easy. You know, let me blow this up a little bit. Sorry about that. I forget that sometimes. Cosine 4 pi thirds is the x value, so negative a half. The tangent of that 4 pi thirds is sine over the cosine, and we go ahead and we simplify that. So 2 over negative 1, 2 over negative 1. So you got negative root 3 over a negative 1, so positive root 3 on that, right? And now we're going to go through, we're going to find the reciprocals on these here. So let me, gosh, I still didn't leave myself enough room. Oh, well. Sine goes with the cosecant. So the cosecant of 4 pi thirds, it's the reciprocal, so 1 over the sine, 1 over negative root 3 over 2. Of course, you simplify that and you're left with negative 2 over root 3. Ugh, terrible. Negative 2 root 3 over 3 once you rationalize that. Okay, the secant, let me start the secant over here. The secant 4 pi thirds is 1 over the cosine, 1 over negative a half, or in other words, negative 2. Once you simplify that, that's a negative a half right there. Okay. The cotangent 4 pi thirds. It's the reciprocal of the tangent, so 1 over the tangent, or in other words, cosine over sine. Let me take that down here. Cosine over sine. Of course, we flip that as well, right? So 2 over negative root 3, 2 over negative root 3. That ends up being 2. Let's see, those 2's cancel. Negative 1 over negative root 3, so 1 over root 3. Rationalize that. There is your cotangent, okay? There's your cotangent. So let's make sure that you got a couple of these here. Let's go with t being pi. What's the sine at pi? Okay, so you're looking right here, aren't you? Sine at pi. So your sine is your y value. What's your cosine at pi? Your x value. What's the tangent at pi? Sine over cosine, so 0, right? What is your cosecant at pi? Ooh, that's 1 over sine. Undefined, can't do that. We cannot divide by 0, right? So we're undefined. What is the secant at pi? 1 over cosine, right? What is your cotangent at pi? And here you want to think about the cosine over the sine definition here, right? Cosine over the sine. Okay, so the cosine here, negative 1. Sine here, oh, 0. Guess what? Undefined, isn't it? In other words, 1 over the tangent also. Okay, so that's at t being pi. What about if you have, extend this a little bit. Let's go with, oops, go full screen. What if t is like, let's go t being negative pi thirds, let's say. Negative pi thirds, okay? T being negative pi thirds, and you're like, well, okay. First of all, pi thirds is like 60 degrees, right? Pi thirds is. So we're actually rotating negative 60 degrees, right? Negative pi thirds. You see that? So you really gotta pinpoint this because this is not, it doesn't show you negative pi thirds on this unit circle. So you're rotating negative 60 degrees to that spot right here, 5 pi thirds. So what you want to do is you want to find the positive coterminal angle. So that's where those coterminal angles come in. Okay, so you say, well, the positive coterminal angle would be if I go 2 pi minus pi thirds. It's all but pi thirds of a rotation, right? So you have 6 pi thirds minus pi thirds is 5 pi thirds. So really, what we're doing is we're finding the sine. When we're finding the sine of negative pi thirds, it's the exact same thing as finding the sine of 5 pi thirds. So I'm looking right here. 1/2 negative root 3 over 2. Okay? 1/2 negative root 3 over 2. Okay, so that pi thirds, again, that 1/2 negative root 3 over 2 is a function of that t real number, negative pi thirds. So I say the sine is the y value, right? The cosine is the x value, and so on. I'm not going to do the rest of those, but you could do it that way. So that's how you go about finding the 6 trig functions for a negative rotation there, right? A negative t value, t number. Okay. All right. Let's move on here. Let's talk about a definition of a periodic function. Okay, these trig functions are periodic. They're kind of interesting, and all right. So the definition of a periodic function: a function is periodic if a, I'll write it down. If for a real number, if you have this real number c, then this is true. F of t plus that c amount is actually the same as f of t. Okay, and that's for all t in the domain of f. Okay, in the original domain of f. And now c, the c has to be the least number for which it is periodic. Okay, so the least number for which it's periodic. So if you're looking at, let me see if I can pull this unit circle up again here. Okay, so if you're looking at this, you notice how if we went around once, right, we were pertaining to that 1, 0, right? But if we went around twice, guess what? It's still, in other words, 4 pi amount, right? We went around once, 2 pi pertains to 1, 0. Go around twice, 4 pi, so we went around 2 pi plus 2 pi, 4 pi also pertains to that 1, 0, okay? So the sine, and how often does that happen? Well, it happens every 2 pi amount, right? So the sine of t plus 2 pi n is the same thing as the sine of t. In other words, the sine of 2 pi, that's your y value there is 0, right? Well, guess what? The sine of 4 pi is 0. The sine of 6 pi is 0. So if you're kind of thinking about this right here as your n value goes up, like let's say it's 3, right? We've gone around 3 times. Well, the sine of t plus 6 pi is the exact same thing as the sine of t, right? Regardless of what t you're finding, okay? So like the sine, for example, the sine of pi halves plus 6 pi is the same thing as the sine of pi halves, okay? So if you were to picture that, sine of pi halves, here's pi halves, right? We've rotated pi halves, but then we're going to go around 2 pi, 4 pi, 6 pi. Hey, guess what? It's the same value as taking the sine of pi halves, isn't it? Okay, so the sine of 13 pi halves is the exact same thing as the sine of pi halves. Maybe I've kind of killed that. Let me erase that for a minute. We'll do some examples later with that. The cosine of t plus 2 pi n is the cosine of t. Okay, so that works equally as well with that one. So let's do Okay, so let's go. How about cosine 9 pi thirds? Okay, you look on here, you're like, wait a minute, there's no 9 pi thirds, right? Well, so you got to break it up. You got to figure out how many 2 pi amounts is there, right? So let's think about in terms of 2 pi, right? Except 2 pi in terms of thirds. Like, for instance, 2 pi, if I'm going to make that into thirds, that's really 6 pi thirds, right? So if you're thinking about this, I'm like, I got 6 pi thirds plus how much more? Well, isn't 3 pi thirds plus 6 pi thirds 9 pi thirds? All right, this is our 2 pi. Well, 3 over 3 is 1, right? So this is really the cosine of pi plus 2 pi, if you will. This is really the cosine of pi plus 2 pi, right? Maybe I should have just done it like that right off the get-go. So you can see, oh yeah, okay. But at least you can work with some fractions now. Cosine of pi, and then 2 pi. I go around another revolution, right? Who am I pertaining to? Right there, okay? So that's the cosine of 9 pi thirds. In other words, the cosine of 3 pi. Well, the cosine of pi plus 2 pi is the same as the cosine of pi, which is the x value, there. So you got to take out the period, if you will, okay? The period, because it's cyclical, right? This period. How often does that happen? Okay. Now the cosine, let's do it. Well, let me do one more. How about sine, how about this? Negative 11 pi halves, right? So you're like, okay, now I'm rotating in the negative direction. Let's see, how many of these is it? 2 pi is negative 4 pi halves, right? Let me put the negative 2 pi right there. Now I got to go some more. There's negative 8 pi halves, right? And some more, negative 3 pi halves. See how that's negative 11 pi halves there? You with me? This is negative 2 pi. There's another negative 2 pi. So this is the same as sine of negative 3 pi halves minus, and you got, see how you got negative 2 pi, negative 2 pi? So you got two of these 2 pi's, if you will. All right, negative 8 pi halves or negative 4 pi. So let's go up. If you look at this thing, you're like, okay, it looks like I'm rotating negative 3 pi halves and 2 pi halves more. So 3 pi halves, first of all, 3 pi halves is 270 degrees. So we're rotating negative 270 degrees. Oops. Okay. So negative 3 pi halves. There's negative 3 pi halves, right? Negative 270 degrees. And 1, 2 more. So the sine of negative 3 pi halves is the exact same thing. Sine of negative 11 pi halves is the exact same thing as the sine of negative 3 pi halves if you take out the periods, which is actually the same thing as the sine of pi halves, because you want to look at that coterminal angle, right? Doesn't that happen right there at 90 degrees? Sure. And the sine of pi halves, the y value there is 1. Okay, that's how I like to think about those. What I'm doing is I like to use those coterminal angles, take out the periods, and then you can kind of see where you're at. All right. Let's do some more here. Oh, you know what? I'm about to finish this segment. Hold on.